When astronomers map the universe on its largest scales, they find a sprawling, intricate architecture. We see a vast cosmic web of galaxy clusters and glowing filaments of gas stretching across billions of light years. Yet, based on the laws of physics that governed the earliest moments of time, not a single piece of that massive structure should exist. If we roll the clock back to just a fraction of a second after the Big Bang, the cosmos looks completely different. It is an unbelievably dense, blisteringly hot soup of early particles and chaotic energy. The particles swirling in that soup, the ordinary matter that will eventually make up planets, stars, and humans, have a critical vulnerability. They interact strongly with light and heat. In this extreme environment, that interaction is a serious problem. The intense radiation acts like a physical wind, constantly blasting particles of ordinary matter apart and preventing them from clumping. Gravity tries to pull those scattered particles back together, but its inward pull is entirely overpowered by the outward pressure of radiation. If ordinary matter was left to fight this battle on its own, it would have lost. The intense heat would have kept it permanently dispersed, leaving the universe as a sterile, featureless void forever. Fortunately, ordinary matter had an unseen ally. Dark matter stepped into this chaotic environment and began to build the foundation of the cosmos. To do this, dark matter relied on its most unusual physical property. It does not interact with the electromagnetic force. It is completely blind and deaf to light and heat. We can see exactly why this matters by comparing the two. On one side, ordinary matter is violently scattered by the radiation pulses. On the other, those exact same waves pass harmlessly through the dark matter particles, leaving them completely undisturbed. Because dark matter ignores this intense wind of light, it is free to respond to the only force it actually feels, gravity. While the rest of the universe is locked in a chaotic storm, the dark matter slowly and silently begins pulling itself together. Being completely unaffected by radiation was the exact physical advantage required to lay the universe's foundation. Dark matter also holds another major advantage. It outweighs ordinary matter by a factor of 5, granting it an immense amount of gravitational influence. As these massive clumps of dark matter grew, their weight pulled heavily on the surrounding space. They carved deep, interconnected gravitational funnels across the cosmos. Over thousands of years, the universe expanded and cooled. Eventually, temperatures dropped low enough that the intense radiation storm finally subsided. With the radiation gone, the scattered ordinary matter surrendered to gravity and began to fall directly into the deep funnels that dark matter had already built. As it collected at the bottom of these massive wells, the ordinary matter compressed. The pressure grew high enough to ignite the first stars and form the earliest galaxies. Dark matter acted as the indispensable scaffolding of the cosmos. It held the structure of the universe together, waiting patiently until ordinary matter was ready to take shape. When astronomers look at the vast webs of galaxies in our present-day sky, they are observing the exact blueprint laid down by dark matter billions of years ago. Physicists can still measure the fingerprints of this ancient construction process by looking at the lingering heat of the Big Bang, known as the cosmic microwave background. This diagram shows the temperature fluctuations of that ancient light. The specific pattern of those subtle ripples aligns perfectly with theoretical models of a universe outweighed 5-to-1 by dark matter. This physical evidence confirms that dark matter is the fundamental builder of our reality. It forces us to reconsider our place in the cosmos. Everything we see through a telescope, everything we can touch, and everything making up our bodies is only a tiny fraction of what actually exists. The stars, the planets, and our very existence depend entirely on a massive, invisible substance that we still cannot truly comprehend.